types of fire. One is cellulosic fire, and the other one is hydrocarbon fire. Cellulosic fire comes when the material, the ignition material, is from cellulose. Like what?
Wood.
Like wood, paper, cloth, carpet. These are cellulosic items, cellulosic material. When fired, we call it cellulosic fire. Hydrocarbon, when the material comes from oil or gas derivatives. Oil or gas or its derivatives. We have fuel source here is petrol, diesel, gas, plastic, PVC. All these material are hydrocarbon or hydrocarbon derivatives. So when it's fired, we call the fire, or we class the fire as hydrocarbon fire. Under hydrocarbon fire, we have two types. First one, we call it pool fire, and the second is jet fire. What is the difference? Pool fire, when the material, hydrocarbon material, is under atmospheric pressure. Okay? So, when flame comes, it will burn, causing hydrocarbon fire. And when we can code it, it's coded as H. Then expression like H20, H120 means it's hydrocarbon fire, and we need to protect for 120 minutes, means 2 hours protection. For jet fire, we code it as J. Jet fire, when the material under high pressure, like pressurized gas, pressurized oil, in pipes, in vessels, when this burn, the fire will be worse scenario than pool fire, plus explosion may occur. So we express this as J. And this means of protection identified in ISO 22899. Types of fire will have different scenarios when take place. Cellulosic fire is normally, is not normal actually. For cellulosic fire is giving temperature, high temperature in long period. For example, it will come to or reach 950 in 20 to 30 minutes. But hydrocarbon is different, worse. It will reach 1,100 Celsius in maybe 5 minutes. If pool fire, and for jet fire, it will reach 1,350 Celsius in 5 minutes, plus explosion may occur. That's why hydrocarbon fire or hydrocarbon expected fire need more protection or less protection than cellulosic fire? More protection. That's why we may use different materials for hydrocarbon fire protection, or same material like cellulosic but in higher thickness. Okay? Cellulosic fire, hydrocarbon fire, and this is the estimated temperature from both of them. When hydrocarbon fire, it produces hydrogen and can be explosive. Hydrocarbon fire can be atmospheric pressure like pool or under high pressure like jet fire. The main problem from hydrocarbon is when it's started under high pressure, because it may cause some effects, explosion. So we have here a quiz. Select the correct description of hydrocarbon fire. What hydrocarbon fire? Is it A, hydrocarbon fire produce hydrogen and this is exclusive? Hydrocarbon fire can be atmospheric pressure pool or under pressure jet? Yes. All hydrocarbon fire are started from fuel under pressure?
Yes.
No. We have pool fire, no pressure. All here. Hydrocarbon fire can be atmospheric pressure
Wrong.
jet? No.
Wrong.
Atmospheric means pool or under pressure pool? No, it's jet. So what's the correct answer? Only B. This example for the exam questions. Example of the question you can find in exam. You have to select the correct answer. Sometimes you will find some 2-3 choices you can choose. You can select as a correct answer. Explosion hazard. When we have some tank, some vessel under high pressure containing hydrocarbons. In case of fire, what will happen? Just imagine, don't look to the screen, to the slide. Just imagine. We have some gas, we have some liquid in or within one vessel. Exposed to high temperature. I'm not speaking about fire right now. Exposed to high temperature. What will happen for the gas or liquid? Expand. Okay? If the temperature reaches to 1100 outside because of the fire, what will happen? Explode. So, explosion may occur in vessels, tanks, or under pressure, the high pressure gas or liquid. We call this as BLEVE, boiling liquid expanding vapor explosion. Boiling liquid expanding vapor explosion. Does the PFP products withstand to explosion? Normally, no. Normally, no. But some manufacturers say we can avoid that by good protection. Actually, these real photos from the job sites or from some plants. If you remember, the plant exploded in Yemen some years ago. It was some ignition source came to the gas. The gas under high pressure inside the vessels and pipe. So what happened? The whole plant disappeared in maybe 3-4 minutes. Disappeared. Explode and fire everywhere. So we have here some video for BLEV, boiling liquid expanding.
When a tank is exposed to sustained heat, such as from a fire, the liquid within the tank is forced to boil or vaporize, resulting in increased pressure in the tank. To prevent overstressing the tank, the relief device activates, venting the excess pressure. As pressure decreases in the tank, the valve begins to close. With continued heating, pressure again builds, causing the relief valve to reopen. Where flames impinge on the tank below the liquid level, the liquid absorbs the heat, allowing the tank metal to remain at a safe temperature. With continued relief valve operation, the liquid level drops, exposing a greater area of the tank to the effects of heating. With the flames impinging on the vapor space of the tank, the temperature of the tank metal, uncooled by liquid, rises. At some point, due to the vapor pressure from within, the tank metal begins to weaken, stretch, and eventually tear. As the tank comes apart, large quantities of both liquid and vapor are released in a powerful explosion. The heat
So the main reason here is expanding the vapor or the liquid, the gas inside the vessel, which increases the pressure. When the pressure increased, the relief valve will start to open to release the high pressure. But the point is, this gas or liquid coming out from the relief valve, what will happen? It will burn more, right? So, what is the correct method to protect this tank? If we cover by PFP from outside, it will cool down the surface, it will cool down the metal, the heat will not transfer into the liquid inside or the gas inside, then it will not affect boiling, it will keep its material as cool as possible, then explosion will not occur. Okay? You got the point? Yes. So,
heat radiated is sufficient to ignite combustibles and cause burns great distances from the explosion. Tank sections containing rapidly igniting fuel can become flying missiles, traveling great distances, causing secondary fires and other damage.
the point is, the explosion scenario cannot be expected. We don't know. It will fly up, it will be distributed all over the area, how the parts from the tank will be flying or flowing in the air. So the scenario of explosion is never been expected, or you cannot expect it. So that's why we have something called fire mitigation. The engineer will design fire protection to the plant, either by active or passive or both. We have active fire protection, we have passive fire protection. What's the difference between active fire protection and passive fire protection? Do you know? Do you know the difference? No. So you are at the right place. ICorr PFP course will let you know the difference between passive fire protection and active fire protection. Active fire protection means we have some system to control the fire by actions, like extinguishers, like sprinklers, like powder.
Fire breathing system.
Okay, these are active fire protection. Deluge system, okay, but this need to be checked regularly to ensure it's fit to work. It may protect from fire, it may control the fire, it may not. Passive fire protection means using some material to protect the steel from fire, like coating material, like boards, like jacketing. All this material can be classified as passive fire protection materials. Okay, bye.